the last 11,000 years, that's since the Ice Age, this our interglacial period has been unreasonably stable. And we don't know why. With an enhanced greenhouse effect from burning of fossil fuel, CO2 and methane and so on, you would have a gradual increase in temperature. That's what all the models show you. It's sort of a gradual increase in temperature. But that's assuming that the climate plays nice. And we actually know from the ice cores that the climate does not play nice all the time. Right now, by emitting greenhouse gases, we are doing the same with the climate system as the investment banks in the US did when they were selling subprime loans in the economy in 2006 and 2007. In the last million years, there's been a cycle of approximately 10 ice ages. And they were sort of around 90,000 years long, each of them. And then there was an interglacial period separating the ice ages of about 10,000 years. That's sort of the standard rule of events in the last million years. If we then zoom in on an ice age, you see that inside an ice age, the climate is extremely unstable. And you have this sequence of abrupt climate changes that happen basically from one year to the next. And it swings from semi-cold to very cold, semi-cold to very cold, within very short spaces of time. But each of these cycles is about a couple of thousand years long. And we had that 26 times in the last ice age. All the big cultures in India, China, Mesopotamia, Egypt, South America, all came after the Ice Age. So we are assuming that this is the standard. Our collective memory refers to this as this is normal. And maybe by enhancing our emissions of greenhouse gases, we are actually tipping the climate system to become yet unstable again as it used to be. We can face a climate change that happens just as sudden as a financial crisis. We have tons of examples of climate changes where we see complete reorganization of the atmospheric circulation from one year to the next. And that will be extremely hurtful for any agricultural activity in the world because the weather will change and will not change back. Fast climate transitions, these abrupt climate changes that we see recorded in the Ice Age, they were discovered in the Greenland ice cores. But now they keep finding them everywhere in the marine sediments wherever they look. But when it comes to Antarctica and the Southern Ocean, you don't see them. What you see there, it's also a wiggly climate line, but opposite. So when it's warm in Greenland, Antarctica cools off. And when it's cold in Greenland, Antarctica warms up. So these abrupt climate changes, it's an internal oscillation in the Earth climate system. What if what we do now is introducing so much fresh water into the North Atlantic that the North Atlantic current would sort of stop? That would make it terribly cold in Denmark, where I come from, because all of Northern Europe is placed at completely unreasonable latitudes. Just because we have the North Atlantic current, we have remote heating, so to say. If that's going to be switched off, we're getting very, very cold. But still the Earth could get warmer on average. It's just a distribution problem now. In principle, there's no reason why the Earth could not get warmer, but still Northern Europe and North America could get cold. Still, that area is not large compared to the global area. What we know from the sudden climate changes in the past is that these abrupt changes represent a reconfiguration of the entire atmospheric pattern. What if, with the emission of greenhouse gases, that we trigger a situation when this system all of a sudden goes into a feedback? If you reconfigure the transport patterns of high pressures and low pressure systems over North America and, for instance, Europe, but particularly North America and the Midwest, and all of a sudden it stops to rain, and it hits the Midwest in the US, and it leads to massive crop failure, that's going to impact the entire world. We don't know. We don't know where the threshold is. But we are rats inside the experiment.